So this one, I was struggling with how to title it, because what's interesting, oh, wow, it's really loud. Is that loud for you guys? No? Yes? OK. Yes? Good. All right. Well, he's in the back. He'll set it. Just sounds really weird here. Anyway, so how many people here are developers? OK. Is there anybody here that's operations? And I'm not getting into the argument of DevOps kind of thing. This is more of like running things. OK. So that was the thing I wanted to make sure is, because we're talking about patching, usually developers go like, oh, that ain't for me, so I'm just out of here. The whole model of this is you are responsible for the end result here. So I wanted to make sure that was headed for you guys, which is both powerful, scary, and could be fun too. So that's good. I'm glad we got everybody here. Who's actually got stuff in production? OK. And who's actually actively developing in containers of some sort? OK, good. How many of you are here like, what the hell is this stuff? OK, fair. Thank you. That's cool. I've been doing this for a couple of years now, and the session Glenn and I did yesterday, we were surprised. We didn't think we thought we just talked to each other because we were pitching against Hunter and Hanselman, and like, you sure you're in the right room? So it's been fun working on this, seeing people when you start out, and there's like 10 people in the audience, and they all want to know, what's a container? Is it round? Is it, and then to get to the point where people are putting in production is pretty fun to see. The new challenges that people come up with, and to actually start to see the fruition of all this work you put into things as customers really start to use it. So it's a lot of fun. It's a lot of scary. It's pretty cool. I put away my phone, so let's see what time it is. All right, we still got a couple more minutes. Anybody have any random questions before we get started? Anybody willing to like actually stand up and say something? No? So there's been a lot of talk around, we noticed today our booth was underneath microservices, and that's been a big buzzword. So who would say they're actually building microservices? Who's going to raise their hand because it's just cool to say microservices? Yeah. Yeah, do you want to?
No, I do want to.
Oh, you do want to? OK. What's cool about it for you?
So I work for the DoD, and we have a lot of legacy apps.
Uh-huh.
So it'd be extremely nice if we can rewrite those.
So the DoD wants to write, as legacy apps, wants to rewrite those in microservices. Should we be scared?
No, the CIO is.
That's fair enough. Yeah, it's funny to see. It's like the term microservices, just try to define that. We got to the point where I don't even want to put that in the title because you get into this religious war of what it means. So it's fun to let everybody kind of come up with their meaning. And it depends. So I'm not going to try to define it. Beth Mossy did the title of the talk yesterday, and we were like, OK, how are we going to? So it was fun to talk about that. It's just some units of small deployment. For me, I like to think of them as they could fail at any time, and failure is a thing. I kind of think of that's one of the things that microservices enables, containers enable, is we accept failure as a reality. We were playing with some ideas on how to coin, what phrase we wanted to kind of coin there, and is that the more you strive for perfection, the more destined you are to fail. The more you accept failure, the more likely you are to succeed. So just kind of a fun way to think about it. Let's see. Cool. Is there an evening event this time? So like an attendee party? Tomorrow? Where's it at? Seattle Center. OK, that should be cool. That'll be fun. Who's from Seattle? Oh, you're all going home. Who thinks they're the furthest from Seattle? Where are you from? Huh? Sweden. Who's further from Sweden? All right, some hands went down. Wait, you just said you're from Sweden. Now you want to be further? Oh, he's next to you. Where are you from? Romania. OK. It's funny, when I look at our geo-replication map for a registry, there's like this big hole in that part of the country, or the part of the world. So we want to see when we're going to get one there. Who's further than Romania? Where are you from? Ukraine. I have to look at a map. Is this like a little bit? A little bit further. All right, you're going to take any chance you can. OK. Anybody else? India. Yeah, I guess yeah, okay. I did this with my daughter who went to school, and I live here, and for some reason she wanted to go to Ole Miss in Mississippi, and everybody that hears we're from Seattle, they just go, why? Like, what are you doing here? And the same thing from there, they go, why'd you come here from Seattle? So we actually, other than outside of the country, we actually won the furthest distance when she was there for orientation. So, all right. All right, anyway, so why don't we get started? I think I am at that time. All right, well, thank you for coming. So today I want to talk about what do you do when you kind of get past that first deployment. So who's actually got an app in production? All right, who is working on their second app and they stop making changes to the first app that's in production? Okay, so you got a couple. That's kind of the theme that I wanted to touch on today. Because containers are the concept of immutable, which means that we don't change them once we build them. And when we want to patch things in production, usually it's somebody else, and we don't worry about it until they tell us it failed. So it turns out that in containers, we don't want to patch running containers. We want to update the container, test it, and deploy it. And that's the main theme, because we don't really, we as developers are the ones responsible for that and setting that up. So I'm Steve Lasker. I'm a program manager. I've been working on the container tooling for a while, and the most recent stuff we've been working on is the Azure Container Registry and some stuff around OS and framework patching for automatically building your images. So I'm going to take you through, I'm kind of play this little game of go forward, explain, show the path, and then come back and kind of explain some of the details. And I'm hoping most of you are familiar with building containers, so this, as far as Docker build, but I want to touch on a couple of key pieces of that. So there'll be a little bit of that theme, and personally I hate movies that go forward and back and forward and back, but it seemed like the best way to explain the way I'm doing this, so we'll see how it goes. So we have this demo 42. We were trying to figure out what to call the thing. We had this, whether we're trying to do important and non-important parts of the app that were reliable and didn't care. That was from the demo yesterday. And we came up with just random names. And then I realized we kind of had a Hitchhiker's Guide to the Galaxy theme going on. So thus the don't panic model. It is really cool. It's not quite as cool as launching a car into space, but for us mere mortals, this was about as far as we can get. The app has parts that can just fail. That's just part of containers, and there's the critical part that we want to be successful with, and the important part. I shouldn't say critical, it's the important part. And the app is set up that way. I'm going to go demoing through this. Is it uses GitHub, so you can just get to the source code yourself. I've tried to put as much of the demo steps in there and the way you could create it on your own. There's a Git trigger that will trigger the build feature of ACR, so it'll automatically build. It'll then go into ACR, it's geo-replicated, and then we'll use Jenkins to do a Helm deployment to Kubernetes with a couple of Azure resources to handle persistence. Seemed like enough moving parts here to kind of make for a fun demo. Nothing could possibly fail. So then, just because I wasn't good enough, we wanted to show the geo-replication features where basically across the pond, so to speak, we have another instance. And in this case, I wasn't actually trying to show load balancing across two regions, rather two deployments of the same app that have arguably localized content. So if we switch over here and we look, we have the app here in East US, and just got random quotes that come through here. And then the same app is deployed in West Europe, and I didn't realize that I defaulted that all of Europe is now speaking English. But that wasn't really the argument, the point. It was just a matter of the same app is configured to run differently in another location because we extract configuration out of it. So, and then the whole idea is after the app has been deployed, we want to make sure that we can patch those containers that are running. So we're going to trigger git commit, be triggered by base image updates from registries where you might be storing your base images. So with that, one of the things that's interesting to think about is the architecture itself of orchestrators. And this is a matter of how does the infrastructure of containers work, and why do we build things a slightly different model? This is what I refer to as the paradigm shift. If you're just using containers as a release mechanism, then you're really not getting the full benefits of it. And you're not going to, in fact, in some cases, that might cause more problems. So here, what we have is some images that are built, the web, the quotes, the important part of it. Right? Those are 3 different containers. They get built and pushed to the registry. Now, this is part 2 of this animation, or will be later. What I'm going to show here is, notice the tags and the digest that reflect that. That'll become important later. We then tell the orchestrator, hey, keep these things running, and then it goes off and does its job. Right? So it's told to load balance this across 2 nodes, so it's got some redundancy. And then, it's still running. We go to a conference. We go out, whatever it is. And then through the night, stuff happens. Right? So now through the night, in this case, the orchestrator is handling the pager, and it will re-instance the workload that you've given it. So you come in the morning, and you're doing whatever, watching Dilbert, reading Dilbert, hanging out, recovering from your hangover. So that's kind of the orchestrator model. Now, if we look at today's, like as in yesterday or the day before or last week, related to container DevOps workflow, we have this thing we call inner loop. And more inner loop is not necessarily restricted to just your laptop. Think of inner loop as what you do before you commit code. Because who wants to commit code that they're not sure works? Right? Forget the fact that it triggers all this workloads to run on the back-end system. We want to make sure that what we're changing, and might want to actually not be so worried about it. Right? We want to do some quick iterative tests. So there's a registry that our from statements are in our Docker files, and we iterate on that. We commit that code to a source code repository. The code includes a Docker file and Helm charts for deployment as well. They're all just text files that describe what we're going to build and deploy. The build system kicks in. It does a release. It will tell the environment to run these set of containers. And this is just what's cool in Azure, is every time I present this slide, there are more things on there that run containers. Don't think of containers as just a particular orchestrator. This is not the orchestrator wars. That kind of was last year's thing, and it's great. Competition always breeds best results. This is a matter of the way we're going to deploy code is in a container. You get to encompass the environment, the base of OS, and everything that you depend on in your image. Now all you have to do is figure out what are the parameters that get passed into it, not what version of the framework that may or may not be on the machine that you're running on. All of that goes in your container, which is super cool. So now I can deploy to all these things and not have a tight coupling to any one of those services and the versions of things they run. So then we have monitoring in the outer loop, and that's all good. But now we're not checking in code anymore. If you're not checking in code, then we're not updating our image. We're not doing image builds. And way we get OS and framework patching is each one of those containers those images that were in our from statement. If you go look on Docker Hub or wherever you're getting your images from, you'll notice that same tag is being updated fairly frequently. And we'll talk about stable tags and unique tags later. That's how those OS and framework patches are coming in. And we want to be able to get the latest. And if you're compiling code, when you're committing it, you're pulling those in, and your build system's taking care of it. But we need to make sure that that happens later as well. So if we, where was I going with this? Oh, yeah, OK. So now the code is done being committed. Think of it as this house that gets built, and we tear down the scaffolding, and we get to look at the shiny new house, right? Everything's wonderful. But as we saw in that previous animation, where a node goes down, it has to pull another image from the registry to instance it again. So it turns out we actually still need the registry, we still need some management, and we still want to monitor, which is what we should be doing anyway. So we're really not tearing down all of the scaffolding. So and then the other thing to keep in mind is even though your app is perfectly fine, it's not running on that machine under your desk or in a kiosk in some airport location where they just shut off the internet from it and it's running Windows 98 and still fine. It's kind of scary when you look at some of these other systems. When you're in the cloud, they're constantly being updated. And at certain points, not intentionally, but there might be a break that happens, and you want to make sure that you have a way to respond to it. So you want to be able to have this automation in place to keep up with what's going on. So let's talk a little bit about Docker build, just really briefly, because I kind of expect that most people understand Docker build. So what I've got here is, actually, let me come over here and show the project. I've just got a project here with, or a set of projects for those three. And there's the front end, the web front end, a queue worker, and a quotes API. The details aren't super important for this. What we'll see here, though, is there's this multi-stage Docker file. And in fact, let me just kick this off here. I'm just going to say Docker build, and I'll give it a tag of web, and we should always have unique IDs. So let's generate a unique ID. That seems pretty unique. It's kind of like was it Spaceballs, where this passcode was 1, 2, 3, 4, and I had to change it, so anyway. And then we pass it the Docker file. src, web, UI, Docker file. And then I pass it the context. That's the directory. And I want it to be the root. I'm drilling into the Docker file onto the web project because I have tests that will run later as well. So what we have is this multi-stage Docker file where we have the build environment, and then we will publish this. And in fact, let me come over here and show this in PowerPoint, because I actually have some animation here that explains this a little bit better. So you have a from statement, and that's your base. Think of it as the runtime that we're going to publish. We're actually going to deploy. We have the SDK. This is how we want to build our code. How we build our code should have nothing to do with how we release our code. Many of the bugs and the security issues that we have nothing to do with what you need to run it. It shows up in things that get built. So one of the awesome things about multi-stage Docker files is we can keep the thing on the left, which is how we're going to build our code, and we could copy in the elements of our project, and then we're going to do a NuGet restore, and then we'll copy in the rest of the source, and then we'll build it. And then from that built image, these are like interim images, we're going to create a publish image. Think of it as, and it is another image, it's just these interim images. And then we're going to say .NET Publish, which basically takes in the mess of the bin directory. We're going to find the things that we want to actually release, right? The actual binaries and any JavaScript or whatever it is that you need to actually run. And then we have this final image that we're going to say copy from publish and just put those in the app directory on the final image. And then we define an entry point, which is how this container runs. That thing on the right is the thing you're going to ship. There is none of the stuff on the left we need to actually run our container. And that's how you get from a 1.7 gig image to a couple of 100 meg or smaller by what you ship. And in that size, it's not just a matter of the size and how fast you can deploy it, but the vulnerabilities that are potentially in it. So that's the important part. And well, you've seen Docker build, so I don't have to go back over to that. So let's talk about configuration. This is another part that's important to think about because, again, the concept of containers are immutable. That means that you just don't rebuild them. You want to build them once, and then you're just extracting the configuration, the thing that's unique about each environment. And the environment isn't necessarily your staging environments up till production. It could be, I actually want to run this uniquely in staging, production, and I might have 3 different production environments for 3 different departments. They might each have important data that's isolated to them. They might have separate billing, separate management, whatever it may be. I should be able to take that same image and run those things in different environments and deploy them. So that's an important aspect of this. So now we build it, we push it to the registry, and that same exact image is deployed at each place. And we keep on iterating those as we go along. Make sense? All right. So if we take a look at our project here, I've got a couple of things that I wanted to show. So if we open program CS, let's see here. Where do I have that one? In our web project, we are actually extracting. So what's really nice around .NET Core, and this is with any framework, there's a lot of, each one has its own way of dealing with configuration. Just .NET Core does it really elegantly here, in that basically there's a configuration object that you're probably used to working with. How you populate that configuration object gives you lots of different models. When you're deploying to something like Kubernetes, we want to be able to separate out the secret things from being found out, as they shouldn't be in the image, they shouldn't be environment variables. Right? We have to be careful about these kind of things, because what do we see in our logs? Lots of helpful information that helps us troubleshoot things, lots of environment variables, not a good place to have your password or your connection strings or other things. Right? And it's easy to make the mistake, as we saw with Twitter, was it last week or 2 weeks ago? So we really want to make sure we're managing secrets secretly. And here we can add a file which will load in, and even the config path is configurable. And then at runtime, Kubernetes will feed in a secret. And if we look at, let's see, our startup files, we can see our storage account is saying from configuration, get a storage connection string. And where do we have the other startup? Here we go. And our quotes also pulls the configuration connection string. Now, these are extracted out, and I can pass those in through the different configuration classes. And Visual Studio and VS Code can use the local development settings in JSON to do that. If we look at Kubernetes here, there are a couple ways to do this here. So this is a Helm chart for how I'm going to deploy out to Kubernetes. And we see there's 3 different secret types that we're using. And if we see kind is secret, and the type is, in this case, the Docker configuration. This one is opaque, and I have another opaque one here as well. And I've just got 3 different names because I want the quotes. This kind of gets into, I have 3 containers, and there's 2 containers that reference quotes. The quotes actually is only a database connection string, and the web and the worker are referencing a storage queue. That's their handoff between the 2. And if we go out, well, actually, if I look at my Helm deploy chart, let's see, where do I have that? Charts, let's see, create Helm. Well, here is when I do a Helm release, and I'll show this a little bit more later. But you can see is that I'm referencing these names, and see even the connection strings, I'm just yanking them out of Key Vault when I do a deploy. So I'm really careful, not perfect, careful to make sure I'm not checking in anything into code that actually is the connection string that is my deployment. And we think we've been pretty good in GitHub in what we checked in, because it took us a little iterations to get there. And let's take a look at, let's just browse the AKS cluster, and we can take a look at there where our secrets are. So we'll just launch up the Kubernetes console. We'll come down here, and you can see secrets. So this is where you'll see those 3 categories, unless it died on me. No, there we go. And you can see there's the important secret. And I can actually show this one, because it's important, but not important that you can't see the detail. The storage connection string, I'm not clicking on that because I know you guys better. You guys have proven to us time and time again that you can get into these apps pretty easily. And then the app registry secret, this one I can because this is actually base 64 encoded, and Docker knows how to pull this out as part of its configuration. And then what do I have? The quote secret. This is actually my connection string to my database. So these are managed securely in Kubernetes, and then my app just pulls these in at runtime. All right. I think that was it on there. So great. So I got my app ready. I've got my build. I'm doing in Docker files. So I've got a very good isolated way to actually get my code ready. I've got my secrets or my configuration extracted. .NET Core has some awesome ways to extract that out, so I'm not building those into my code. What about the different build systems? So this is also kind of where I talk about the container-first mindset. And if you go all the way, you can see the value you're going to get by building in containers and automating this. So the current build infrastructures that many of you are used to have these build pools. And they have lots of instances, whether it be Windows or Linux. And the model is you pull something off the queue, you submit a build to it, it pulls it off, and you might only have to install a couple of things that you need. Because these images that we've got set up try to have everything you could possibly need, which means they probably have not what you specifically need. So then there's this minor piece that you have to add. And if it's only one or two things and it's fast, no big deal. And then it gets thrown in the queue and another one comes off. Now, how many of you guys have custom or dedicated build servers where you have like a build agent yourself that you're managing? Yeah, it's usually around 50% we see, because there's just too much that's unique. So you build these custom build pools, and you start setting up special agents that run your code just the way you want them. They might be very supportive to run the frameworks you want. They might be unique. They might be something you really don't want to be dealing with, but you have to. Or they might be the cool thing because you got Docker on it, but you're managing that. And who's managing these build pools? Right? You have to care and maintain these as well. You're trying to get code out. You're trying to have a production operations environment, and you have these build pools that you're having to care and feed for yourself. So you automate them. And what happens when you automate things? They kind of blow up. So this is not necessarily the best way to do this. This is a great stepping stone, but what we want to do is we want to throw that out and really get to a container-first mindset where you're just leveraging Docker images because you can bring your own environment in that Docker image. You set up what specific version of the framework, what specific version of the test that you need. You provide that image. You put it in your registry. When you start doing builds, you just say, that's my environment, and go run from it. And now the host should know nothing about the details of how you're running it other than to run your builds as you've defined them. So that's what we've built with ACR build. Let's take a look at what we have here. So if we look at what we did up here, this was the one, yeah. And I'll bump this up again. And if we look at that command that I just ran, you notice it says Docker build. And I said, what, unique ID, so on and so forth. I may or may not have Docker installed on my client. I may not have the same version of Docker on my client that my build server does. So what we've done is, with ACR build, you can actually offload this all to the ACR build service. ACR build -t web. Instead of me generating a unique ID, I can say .build.id and now you see why I put that string in there, but because everything else is just the same. And if you know the way the Docker client works, even when you have Docker for Windows installed in your machine or Docker for Mac, you're actually sending it from your machine to another node that's on your machine. Right? There's another VM instance on your machine that it's a client-server model sending it up to it. And it streams logs back to you. Well, that's exactly what we're doing here. It just so happens the build environment is in Azure. It's next to your registry. And you can actually do this here. If you noticed, I said dot. I'm taking my local directory and sending it straight into ACR build, just like I did with the Docker client. And it's going off and doing its build. And let me just refresh this. Here, I can watch the builds happening through the AZ CLI also. I can see that top one. Let's do that again. I can see that top one in the list. That is my build that's currently running. And notice it said manual. This is what we call a quick build. So I can test it before I've committed my code. I can even disconnect it. It's still running. And I can also say AZR, ACR build task logs. If I just say logs without a build ID, it'll just stream me the last one or the current one that's running. So here, what we've done is we brought you the logs, but not from where it currently is. We brought you from the beginning and are now live streaming it the whole way until it's done. So that's part of the main thing that we wanted to be able to enable. So we'll let that finish up. And if we look closely, but wait, there's more. It's kind of the idea. It's not just around doing Docker builds. We didn't want to do this just because Google's doing it, AWS is doing it, or whatever. The point we're focused on is that OS and framework patching. And if we look at some of the other ones that are done in clouds, you have to tell it what Docker file, what Docker image you want to be triggered on. But what happens when you change the version of the framework you're based on? Because you go from version 1 to version 2, or version 2 to 2.1 that we just released for .NET Core this week. So you can see the image that you've built. And if you notice, there's a runtime dependency and there's a base image that I've managed in my own repo. We'll talk about that in a minute. And it's 2.1. And I have a build time dependency. And we wanted to separate those out because in most cases, you only care about the runtime image that you want to be triggered on, to be rebuilt, because that's what's running in production. The SDK, in most cases, you don't care. There are some compile bugs that sometimes leak in that become an issue, and that's why we track them separately. OK, so where was I at? So I was on, yeah. So now I've got that set up. The next thing I want to do is, it's great to be able to do Docker builds locally and send it up, but I really want this to be set up on my Git commit. So let me just go over and grab a snippet, because I don't want to really type this. So let's see. Here we go. So here, what we're doing is, it's a build task that we're going to create. And I give it a name, Demo42 Web. I can tell it the number of CPUs that I want to use to build it. I give it the tag. Notice I said .build ID, so I give it a unique ID each time. The Docker file. I can do build args. I can do secret build args, which should be a secret, so we don't tell you what it is. And the idea there is, as that's passed in, they're masked. So this is where we're following the Docker CLI that you've come to expect, but we've added some extra stuff in there to make sure that we can bring it that much better. The context is a GitHub repo. I can specify the branch, and the token that it needs to have authentication to set up the webhooks and everything. I just stored that off in Key Vault. So now I've got that set up. Now I just want to do a change to my code. So let's see. I'm going to come over here, and I think I was going to change about. So we'll come to Pages, About, and we'll say hello from 6B, C, something. I don't remember. So I'll save that in here, and then I'm just going to come over, and if I go to my web project, and I was messing with that, so we'll ignore that change. And we'll just say hello. And I'm going to trigger that in, and that will go off, and now I've done a Docker push. And if we watch over here, we're going to see that that build just got triggered to come in, right? I'm watching my list of builds, and that build definition for Demo42 Web was just triggered by a git commit. And if I want to see what's going on with it, I can watch the build here as well. So I can literally attach to the stream logs as they're happening if I'm seeing some trouble, some issues that I want to follow. OK, cool. I think that was what I was doing on build. Cool. All right, so let's come back to slides. So that's kind of the main thing. We're really, like I said, we're focused on that OS and framework patching scenario. And this is where I want to kind of drill into the next iteration. So this is a bit of a roadmap. So I've highlighted some stuff in yellow to talk about the things we're working on. But I really wanted to put context as to why you see some of these components out, because we're very focused on building these primitives because we have an end-to-end picture in mind, but we don't necessarily want to restrict you to the end-to-end picture. So who here is writing code that's not in .NET? It's OK. It's not like you're going to get brawled here or something like that, right? And sure, the .NET team would love to convince you to use .NET. From an Azure perspective, we're happy to have you here, right? It doesn't matter whether you run Windows or Linux. Doesn't matter whether you're running VSTS, Jenkins, Circle CI, CodeFresh, or anything like that. And what we've seen is you're going to pull my build system out of my cold, dead hands after you pull the framework out of my cold, dead hands that I'm using. And that's kind of the passion that we kind of see. And we just want to make sure that people can do the native things. So with this, with the whole concept is we're building these primitives that you can use them in an experience that we put together, but you could also use them in other ways that we don't yet know about. So we'll start with the registry. And one of the things that we need to add is the ability to have a secure by default registry. Because if you look at the way the container workflows work today, you do a build. You may do a virus scan before you push. Maybe not. You don't really, even if you do or don't, you have no control over what somebody did. So when an image winds up in the registry, we want to make sure that you cannot pull it out of that registry until you're sure it's been scanned. So we have this thing around quarantine that we're adding, and we've got a demo of it at the booth that we could talk about. And we've been working with Aqua and Twistlock to make sure that we actually are doing this right. We're not inventing this on our own. So the idea there is the registry is secured by default and only images that have been scanned. You're then going to protect the production nodes anyway, because everybody that knows security knows you need multiple lines of defense. You probably configure those nodes to only pull from a certain registry, but we'll make sure. But we also need to make sure that new viruses that come in that are aware of on running images, we can be notified of those as well. So that's important. We'll do ACR build. So you have this build system that's set up right next to your registry, ready for these different events. We show the inner loop experience where you can actually test things in the actual build system you may be using. We'll use Helm charts if we're deploying to Kubernetes. This is a little bit of a Kubernetes stuff here. But the other part, so how many have got their container builds automated? OK, a couple of them, which is interesting, because the rest of you probably represent this other part of the curve. I was going to put a slide in there that shows this. If we look at our telemetry on the number of operations that happen on ACR in a day, I'll flip this over. It's like this massive curve where the number of pull and push operations are across the left. There are customers that are doing 8 million operations a day. It's just the number of nodes that are pulling and testing, and they automated on builds. And 99% of the images they're pushing never see the light of day, but they're sitting in the registry. So, and even if you deploy them, you're only deploying for a little time, then you deploy an update. So we have this management system that we're working on for policy management on deletes. And this is a pretty familiar pattern we've seen generally, that you can just watch a tag and say, well, if this tag matches this expression, I'm going to delete it. But that's kind of a weird pattern if we think about it. Don't you really want to know that I want to delete all the things that are in production 6 months after they've been no longer in production? Might be an answer. If I do nothing with the image, delete it in 2 weeks. If it's got a vulnerability in it, delete it in a week. And by the way, if you delete it, it'll actually be in this recycle bin, so you can get access to it if you go, whoops. But the model is not just when I released it. Because do you know how long the release is going to last? If you have an image that was deployed in January, and you say, I want to keep my images for 6 months, in 6 months and a day, when one of those nodes dies, can it pull the image? So what we want to do is monitor the release systems, the places where containers are running, let it phone home back to the registry, and it'll tell the registry, by the way, it's still running. And the registry will say, OK, your time to expiration is 6 months from today. So now we're starting to put some things in place that can actually kind of help you on that full life cycle. That's part of the purge management features that we're working on, and we'll hopefully have out later this year. Now, we talked about code stopping. But we still need the rest of this stuff in place. So this is where the other part of ACR build comes in, is we can monitor the other registries that you may be pulling your images from. And then as those images come in for updates, we can trigger that build and automatically build, test, run, deploy your updates. Okay? So that's part of it. Well, actually, I guess that was the end of that one. So that kind of gives a picture of a big piece of what we're thinking about from the lifecycle of container workflows. Now, ACR build is, triggers on Git commits, which is the most common thing, but we also can trigger on registries. And right now, we work from the same registry because we're working on that iterative cycle. If you're doing a demo, you're not going to wait for something on Docker Hub to update because you probably don't control it. So right now, we do same registry notifications, but we've got work queued up for Docker Hub and MCR and other registries as well. And the idea is, while we will have this native build service as part of the registry, which will be geo-replicated everywhere you have your registry, so it's always close. We're not trying to take on these other really robust systems. You would be able to integrate your build system or your release system. You may not need the build system that you're using today. We hope a lot of that will be encapsulated in your Docker builds with some additional steps. So we'll have multi-steps there. But our goal is not to eliminate it, it's to integrate with these. So let's take a look at some builds triggered through Git commits. Oh, I actually did the Git commit. So, wait, yeah, I actually already did that part. I jumped ahead of my demos already. OK, I combined the two there. All right, so I showed how Git commits could trigger an update. Did I actually show it deployed? I guess I didn't show it deployed, did I? So here we can see, where did I put, I get it in the About page. So I said hello from 6B, and notice that's East US. And if we go here to West Europe, it was deployed there as well. And I'll show some of the release management when we get a little further along. But the next part that we wanted to show was testing. And let's talk about that. OK, so who runs unit tests? OK, who's going to admit they're not running unit tests? OK, somebody's being honest. We give them the cookie or something, I don't know. In many cases, it's not really as critical today, depending on how much automation you're doing. This is becoming more and more of an issue because we really want a goal for complete automation so we can go home at night, things happen automatically, we can focus on code. But we want to put some gates in place to make sure things are safe. Now, unit tests are fairly straightforward. You can do things like you can run a unit test in your Docker file. In this case, I'm just using .NET Test, and we'll demo this here. So let's go off and do that. So we're done with that. We're done with that, done with that. OK. So if we come back to our project, you'll notice that next to the web project, we have the source directory. We also have a test directory. So we have some tests that test the index page that will, as they're run, it's making sure that what data is put in comes out. This was part of the thing where we didn't really want to trust a text box that was open to the, unsecured, that in the last presentation everybody can type in whatever they want. It was originally going to be you guys were going to give us the quote of the day. We thought a little bit more about that and said, let's give them a quote that we'll put up there. So in this case, when I'm not connected to the quotes API, we have this little piece in there that basically tests the hack that if you didn't give us what we expect, we just say, yeah, nice try. So it turns out that that shows up in our test as well. But what I also wanted to do was test the base image, some expected behavior that I expect from the runtime that I'm on. Now, you can't always test for the unexpected. So it's a little bit interesting here. So this is why I kind of mess with it a little bit. So all I'm doing is, in my test project, I pull an environment variable that I just set to something unexpected. I write it out to my logs, and then I'm testing for what I expect to be there, good or great. Right? So just an interesting test. And then in my Docker file, what I'm going to do is simply run those unit tests after I do my build. So we'll save that. But of course, we don't want to commit that. We want to actually test it first. So I'm going to clear this out. So I'll say ACR build, and not a task, because I'm going to build locally. And I actually don't even need to give it a tag, because I actually don't want it to push to the registry. Web UI, Docker file, and -- no push true. And then I give it dot. So what it'll do here is it's going to build my project, run that unit test for the expected behavior. It's running it in the build environment I expect to check in my code and run completely as well. So we'll let that run. And let's drill into the next part. So unit testing is great. Definitely, you compile your code if it's a compiled language. If it compiles, step 1. Unit testing, step 2. That's not enough, though. And especially when you think about multi-stage Docker files, I'm going to test that environment variable, but that's only in the SDK image, because my unit tests are running off that. It's not running on my production image. Now, you can do some stuff there, too. But usually, the problem might be your configuration isn't right in a particular environment. So what we want to do is do the next stage also with functional tests. And the functional test is run some containers, run it with a test runner next to it also to test that functionality. So now using something like Brigade and Helm, because Brigade's an awesome scripting environment for things like Kubernetes and Helm for deploy, I'm going to deploy my containers, and I'm going to have another runner that communicates with it that is keeping track of what's actually running in that environment. Just composing up or spinning up a container in some build system, that's not a functional test. It's one step better, but does it really give you the comfort you need? So this is the kind of a really much better model. I was going to spend a bunch of time drilling into this, and I realized I didn't have the time. So I did find this. Dan Garfield from CodeFresh does a really good video on this. So the link is there. Ignore the last 10 minutes where he talks about how much he loves Google GKE, but that's OK. Not everybody's perfect. They're doing some cool stuff. But anyway, that's kind of the model, is we want to do the functional test as close to production as possible. And things like dev spaces are a great example of how you can do that as well. All right, so let's come back, because the cake has been cooked a little bit further. And if you notice, what do I have? I got some red text, which in itself is kind of cool, too. We don't just stream logs in black and white, because the world is color. We like the other side of the rainbow. So we can see that our test failed. And I spit out value tested. Well, it turns out the new version of the framework is amazing. It's not just good or great. And I didn't expect that, so my test failed. And then my build fails as a result as well. So if we look here, you can see, we can see that last one will be a manual test, and it has failed as a result. Right? Manual error, and just tracking that. So how are we going to fix this? Like any good project, we're going to do what? Fix our test. Because it's not our code, it's the test that went wrong. I've learned to copy and paste because I never type the right thing all the time. So now our project is working. And of course, what do? We just commit it, and we're good. Tests fixed. And we'll push that up. And if we come back, we'll see that now that will trigger up, and by git commit will kick in. And not only will it run my build, but it'll run my test as well. It'll run my test as well. It'll run my test as well. I did trigger it up, didn't I? My watch command, let's see. OK, so there it is. So that's running. And let's talk about the next step here. Where am I? OK, so we've got we got unit tests. I didn't have time to drill into functional tests. That's a session all by its own. You get the concept. So now let's talk about running. Now we've got our code set up, we've got our build, we've tested our build before we've actually even deployed it, we've tested our build system, and we've got some unit tests in there. Let's get this running. So if you're using Kubernetes, Helm is a great way to define your template and how it's going to deploy. And then, of course, we have the Azure Kubernetes service. A quick primer on Helm, because in itself, it's a whole other talk. Helm charts, so who's familiar with T4 templates? OK, think of T4 templates on steroids. They're Go templates. So when you look at this hierarchy, you'll see a chart in the root, and that's the name and version. And the idea is you can build a chart that others can consume from you. In fact, if you look at the bottom, you'll see Nginx. We reference the Nginx chart. Like, I want to deploy that, and that has its own definition for how it gets deployed. So it's just a hierarchy. We have custom templates that will expand out. There's you could have other templates you reference. You could have values you pass in from a static perspective. But the main value for Helm charts is I can pass in dynamic values. So I can set name-value pairs. In a release, what's the most obvious thing that you're going to change every time you release? The what? Environments, right? If you go to different environments, the different environment variables would have to come in. What if I'm releasing to the same environment, an update? Version, right. And version's another interesting one. I love we can get set up on this. So let's quickly take a look at, just going to review deploy configuration. So, OK. So actually, we'll come over here first. So what I have in my project is under the deploy project. So you'll see this in GitHub on our demo 42. There's a deploy project. And I've got this set of files that are how I create the environment. I got a little over-pivoted on the CLI, so this is not to mean you shouldn't use ARM templates as well. I was just having fun here. I have my whole demo script that I run here as well, so you can leverage that. But I also have the Helm charts. So you can see the chart. We call it demo 42. It's got a version. I've got the values that I would do the first time, but notice there really isn't any values in it. It's kind of an interesting one. There's things just to get it started, because I never want to put my configuration secrets in there, for instance. There's some requirements. In this case, it depends on Nginx. And if you notice, under charts, there's the Nginx, which is actually just tarred up. It's just a zip of all of the detail that you see here specific to Nginx. And then under my templates, you'll see here's the web app, and here is just the expansion of macros to no extreme. And we're just seeing a whole bunch of names that are referenced and all these levels of indirection so that I can do things like I can pass in the image name. That's all I want to do, or pass in the secret or the configuration for the database. And if we look at, let's see, when I create the Helm chart the first time, when I first set this up, I can do a Helm install, and I even environmented so the thing to the left is where does the Helm chart live? So I deploy this from the root of the deploy directory. The name is demo42-int. -prod, -finance, right? Whatever I happen to be doing. There's a host name, which is the DNS host name, such as demo42.east.us, blah, blah, blah. The quotes API, this is the image. And notice even the registry name I've extracted, because I wanted to try to make it easy for you. If you're going to run this, you can't run it on our Jenga demos registry. It'll be your registry. So you can put that in as a variable. And then the storage connection strings, they're just referencing key vaults, queue names, so on and so forth. Now, I do that initially, and then on each release, I just have a script set up. Where is my release? Release. And here I happen to be using Jenkins. And so the model that I'm doing here is I've got webhooks set up on the registry, and the webhooks call the release, the Jenkins release. And in the payload of the webhook, it says all the information about the image, including the version. And we'll talk about versions, but the version is the tag, because I want to release that uniquely each time. So I just parse out a variable, and we'll look at how that gets set in a minute, and if the variable has web in it, run a Helm upgrade, reuse all the values it has already, like the connection string, because that didn't change, and just set the web image to be the updated image tag that I want, including registry, repository tag. All right? So that'll say jengademos.azurecr.io/demo42/web:AAB6, whatever. And we'll take a look at that. And I just do that for each one. All right? Now, if I come over to here, what you'll see is under release, I've got 2 release definitions, one for East US and one for West Europe. Now, why would I have 2 release definitions? Asynchronous time. So if I push the image on East US and it gets into the registry, assuming vulnerability scanning isn't kicking in, when the push is done, I should be ready to deploy. So I can tell East US to go deploy. But it's not at West Europe yet. It's still replicating over. So this is some bugs we see sometimes, is people, as soon as the push is done, they think they can deploy. If you listen for the webhook will fire when it's there. And now I can say, oh, the image is actually there. Now I can do the release. So I've got one for East US, and I got one for West Europe. So when the images arrive, then it can do its work. That'll also get important when we think about this thing we talked about with quarantine, because when I push an image, it's not immediately available. It's got to get scanned first. And only if the scanner says OK will the image be allowed to be pulled. And we'll fire that out with webhooks as well. So if we look at the definition here, and this is just a release definition, and again, this works for any one of your build and release systems. There's nothing really magical here. All we're doing is we pull our repo from the deploy project, because release has nothing to do with the source code. The source code was already compiled into one of those 3 images. I happen to be pulling off master, and then here, what's interesting, all right, so here's a build trigger, and we just got a token, which I did expose it here, but the worst thing you're going to do is trigger my builds all the time. And here what we're doing is, because the webhook has a payload that has the information around the images, you're just pulling out, creating an environment variable, and doing a JSON path into that webhook payload. And I set the registry, the repository, and the registry being jengademos.azurecr.io, that's referred to the registry. The demo42/web, that's referred to as the repo. Repos are like such an overused word. And then the tag is the thing to the right of the colon. That should be your version. Tags get overused in a lot of different ways. I would say the tag should only be unique for that repo, and that repo should only contain one thing. And then the last part is for East US, I grab the kubeconfig, and then I say run the script. Because the script is the same for East US and West Europe, because everything has been parameterized. And the parameters just came through my webhook for what I need to do that's unique per. So every one of your release systems have patterns like this. This is just an example. And the other thing is, you notice, if I need to change something about my release, I'm not having to go back to my release management system and click through a whole bunch of things, type in a bunch of things. I'm referencing it to my code. So on my desk, I can make a change. I can validate it. And then the release system, I don't have to go this check-in, check, check-in, check kind of game again. OK, that was release. So that was that. I know there's a lot in here, so I'll be around afterwards to answer questions, therapy, drink, whatever. I've been doing this for a while. I can tell you it's fun, it's frustrating, and it's rewarding. And you're like, why the hell's it got to be so hard? So I can tell you that is why there is a host of people all over the floor downstairs that are actively working on making all this stuff easier. So that's a common thing we're working on. All right, all of that was set up for why this very simple demo that I'm about to do is all the investment you've made up front. So let's take a look at this kind of overview, because it's easier to show it in animation than the end result will be the demo. So on the left, you have some base images. Your .NET image, your Java image, your whatever. It might be Alpine, might be Windows Server, Nano, whatever. You then create a build definition, a build task. So, sorry, you have a Docker file that says from an image. And I didn't have enough room in boxes, so I didn't care what framework it is. It's just the framework. Okay? You create a build task that says, give it a name, give it a tag, build ID. We'll talk about that more, but you just notice it's always the build ID. It's always unique. Some repo, the token, and the registry it's associated with. So now you commit some code, and ACR build kicks in. When the build is done and done successfully, which means your unit tests passed, as we incorporate functional testing into this, as functional tests pass, that we will save the dependencies I highlighted, right? I showed the runtime and the build time dependencies. We can track that. By default, we track runtime. You can optionally tell us to track STK. By default, we trigger builds on runtime. You can also tell us build time dependencies as well, or don't trigger at all. Those are options. So then the push is, we push to the registry, and as it goes, you'll do functional tests. Your functional tests have, the container model I showed, and then if your functional tests are done, you're going to do your actual deploy. So that's all well and good. But now you've got framework 1. Well, it turns out, and we're watching framework 1 for that specific build task. The framework 1 ships a vulnerability patch. There's some critical issue, whatever it may be, SSL, whatever, pick the vulnerability of the week. And you want your builds to trigger and pull that update in. So notice it wasn't a Git commit, right? That build is going to fire again, and we will pull that in. We'll save the digest by which that was updated, because it was updated based on the same tag. And then the same thing goes on, right? So the only thing that's really changing is the base image update triggers that update. What we're doing that's unique to ACR build compared to some of the others is we're parsing those triggers from your Docker file. When you go and change your Docker file to, say, version 2 or 2.1, we're not going to be triggered on version 1 anymore. We've picked up that change. You don't have to worry about that keeping in sync. You don't have to be yet another bug of, why does my images keep on getting built? It has nothing to do with the framework that I'm working on. We'll pick that up dynamically, and then monitor framework 2, which, so see it's framework 1 and dependencies, and then framework 2 will track there, and then you can trigger your build off and you go.
Quick question.
Yes?
When the base image gets an update, do you actually rebuild the web application?
That's the idea. Yes, the question was when the base image update comes through, do you actually rebuild the container? And yes, that's exactly what we're doing, because containers are this concept of immutable. You don't want to take a container that's running in production or running anywhere and go and update it, because that's.
About my application, will you be getting it from GitHub and then rebuilding the web application?
Oh, is the question where does the source come from that goes into the container?
Update the base image. There's an update base image. It kicks off the build, and your Docker multiple compose file, I assume you are going to run it.
Right.
As part of it, you are going to put my latest source code and rebuild it and create a new container. But what if that's not what I want? I want my binaries to remain the same. I don't want to recompile my application, but just update the underlying base image and put my
Right, the binaries from the last build.
my binaries just laid on top of it.
Right. So the gentleman was just asking the question, what happens if, so what happens here? Does it actually do a git pull? And there's a couple of different switches. For right now, it does do a git pull because that's part of what the build pipeline is just default setup. But it's going to do a git pull on the commit that we had. So we track the commit ID, by the way, in there. So, but the real question was, I don't want you rebuilding. I want you to take the compiled binaries that happened previously and reuse that. And I'm not sure if the specific reason is, but we've heard there's certification that got done on those binaries, and different groups have agreed that you can deploy updates as long as you don't change the binaries. Even though they're rebuilt from the same source, but it gets into some interesting games if you're curling in your Docker file as well. So what you see in the animation, if you look close, there is this, let me see where I highlighted it. Yeah, see how it says context, that middle one? We don't have this fully implemented yet, but the idea is that when the build is done, we actually save that build context that you've done, and then when the build runs again, we can just pull it out so we're not going back and getting the source from its location or rebuilding. You can literally stash that off, and then we can just pull from it again. That one takes some more work because you can't really tease out in a single multi-stage Docker file. What we'll need is a second step. The first step is go get all the things that you want, including curling a package in if you want. It could be doing some builds, and then you save that context, and then you would fire the next step in the, not the Docker multi-stage step, you'd fire the next step in the ACR build pipeline. So that's coming. In fact, I'd love to talk to you more afterwards. Okay, so let me go and demo this. So what I've got here is I've set this up with, let's take a look at our Docker file. So if we review our Docker file again, you'll notice that it says from registry name, base images, Microsoft, .NET SDK, and in this case down here, it says from the runtime. But I'm not actually pulling this from Docker Hub. I'm actually storing this in my own corporate registry. The case here is there's somebody in our company that is managing all those base images, and all the dev teams are supposed to pull from it because they've optimized that for that company. Ultimately, we'll support this from Docker Hub as well. We just didn't finish up the caching, the indexing yet. So, and it's also hard to go change a public image on Docker Hub because I don't own it. So we'll come over here, and in the demo, what I'm going to do is change the, actually we'll make it blue. Actually, I'm going to make it green because it helps with the demo later on. And I'm just going to commit this to master because that's always the fun thing to do. So now, if we come back over, what you'll see is I've got a auto build set up on that Docker, that repo that I've set up. So now my base image for ASP.NET Core runtime is now building, right? Because my git commit triggered that build. And then when it's done, because that image, when it's built, will push to the registry, and I have 3 other images that are based on that image, it's going to go trigger those builds. And to kind of get a sense of what that's all going to look like, well, actually, we'll give that a second because it's interesting to watch the little switch over there. So the idea here is you can just simply trigger builds, and you're deferring to somebody else because you've said you really want updates in that. And we want to be able to wire this up because the whole pipeline you're setting up, remember we talked about the automated tests? This is why we want to leverage that, not just for the builds of the life of the app, sorry, the development part of the app, but the entire life of the app. That's your queue. It was about that amount of time, no? And well, this is one of the things we can also show, AZ, ACR, build, task, logs. And we can see exactly where it is at. And it's done. So what we'll also see now is, oh, I see, the refresh got messed up. So now we'll see is that this one succeeded, right, our base image, but notice what happened here. My other 3 images that were based on that image, they kicked in, and now they're building. In fact, we could come over here and say logs, and we'll see that those are running. It'll give the latest of the last one. If I wanted the specific one of those 3, I would just tell it which build ID. OK. Oh, I see. It's actually, they're already done. So if we look over here, what we'll notice is I now have a green image over here, and we'll see if it made it there yet. Nope, it's actually, so here's a perfect example. It's still getting its replication out to West Europe, and once it gets there, Oop, it's almost there. There we go. So here I've just made, I was able to take advantage of an update down upstream, and it trickled in. It took up my build system that was set up, and it ran through. My unit test said it was OK. I said the framework that was amazing was still good. I didn't test of ugly colors was a good or bad thing, and it went right through. So that, and I have one more demo to bring this home. OK, so here's the interesting part. This is why this one's actually makes for a simple and cool demo. To make this work is the interesting part. So imagine you work at Contoso and you have a single returns app that you're working on. For each pull request, you're going to do a build. You do a push, you do a scan, and you do a single test, and then you would do a deploy. And you would do that for the life of your development. It's the normal way we might think about this. So you have a build system set up for that, right? You've got that scaffolding that's meant for the crew that you are working on that particular house. As we're building this container build system, we have to think about all of the apps at Contoso, all the apps at Northwind, and every other app company that Microsoft has ever shipped a sample company for, which was kind of fun to find them all. I didn't realize there was that many. Every one of those apps in every region of Azure is now waiting for a build to happen. So we're monitoring the various repos out there, the registries, and as images come in, we're going to funnel all those events in, and they're going to trigger these builds that are just, you saw one update trigger 3 builds. Imagine when .NET ships an update, Windows ships an update, Linux, Alpine, any one of those. Think of how many images are going to trigger a build. Because as we've been discussing, containers are the new unit of deployment. Wow, that is pretty cool to think about having to build that kind of thing. So one patch is the number of customers times the number of apps for the life of the app. That's just pretty cool math to think about the impact of not only do we get to run a service that is like, wow, can we really do this? We have an amazing engineering team. But the work that you're putting into your build system and your tests aren't just like, it's just for another week, we'll be done with this project, and I don't have to worry about tests anymore. Instead of getting woken up in the middle of the night because your app crashed, and only after scouring logs did you find out that somebody put a patch on that machine that wound up killing your app, and which they're just applying patches because, by gosh, they're going to patch those machines. That's their job, and they have no idea to know what's running on those machines. It's not at all practical to test every patch before you get it deployed with a VM infrastructure. I mean, think of the words Terraform. It's awesome technology, but just as Terraform refers to rebuilding an entire planet, that's what it takes to instance VMs and test them all. Containers, I don't know, it's like a little grassy spot on the roof of your house or something. I don't know. I haven't figured out that analogy yet. OK, so last demo, and we'll call it in, and you guys can go off to the bars and whatever. So this whole conversation came up for the number of issues that we had contacting us on ACR and what problems people were having. And basically, it comes down to a problem of stable tags and unique tags. How should you tag your images? And this one, there's a part of religion, and there's a part of it's the style after you've chosen the religion. I don't know. I got to work on that one, too. Anyway, so this is a variation of the animation I did earlier. Same thing. I'm building those 3 images, and I push it in. I tell it to deploy. Now pay attention to the digests that are associated with those images. When I deploy something, I want to tell it to deploy on a tag. First of all, digests are this long, and you don't want to be able to look at those because you won't know whether it's different or not. So we do want to use tags. So now the orchestrator is keeping that thing running. That's great. Life is good. Now I'm going to go and do another build. When I do another build, in this case, I'm going to use the same tag because it's just a minor fix. I don't want to have to manage versioning the whole thing and do this blue-green. It's minor. I just want to roll it out. And I want it to be on my nodes. So I pushed out another version of tag 1, or whatever tag you're using. And now when that thing goes away and the orchestrator does its job to pull tag 1, or whatever it is the number you've used, look what's subtly different here, right? The orchestrator did its job. It pulled out the tag you told it to keep running, because you didn't want to do a unique deployment. You just wanted to update that minor fix. And now you have an inconsistent state. So this one's a fun one to demo. So we're going to come over here, and I'm going to come up, and we're going to not there, not there. We'll come back to our About page, and that one. And instead of there, we're just going to say red. Right? So we're going to make this change here to our app. And I'm going to come over, and we're going to do, actually, what was I doing? So I didn't do this. Base images. OK. So now what I want to do is take that one, and I'm going to use it. Oh, I remember what it was. I have to go get the tag. So I need to know what tag is currently running under the web image. So we'll come over here, and there's a couple different ways to do it, but it's kind of nice just to show it in the Kube dashboard so you can see where to find some of these things. Most of these, it's just where is the cheese, because it keeps on moving. So I'm going to go to deployments, because that's where I define how I want to. Did it? OK. This is some work that we're doing that this will get better over time. This is just a current state. So if I look at deployments, and I've got a number of different deployments in that cluster, and if we look at the web front end, we can see it gets trimmed there. This is yet another reason why I don't want to use digest or really long things. Hey, did it die already? Ah. OK, I can actually cheat. I happen to know that because I am using the build ID, that's what I know the tag is. So AAJK, and let's just come over here, and I'm going to take this little snippet here that I've set up. So I made that change, and we'll grab that. AAJK, was that what I said? Yeah. And dot. So what I'm going to do, let's think about what's happening here. I'm saying, hey, ACR build, take my current directory and do a build and push to the registry with that same tag, because it's just a minor update. Now, clearly, you shouldn't be doing something like that, a local build and pushing. But imagine you were using git commits as your tag, because git commits should be unique, right? Every time you make a code change, that's a new git commit. So I've seen people, passionately argue they should use git commits for your tagging. And they're absolutely right when code is the only thing that changes and triggers a build. When a base image comes in and triggers a build, I'm using the same git commit. But the content is different, right? So I'm introducing some ability to have instability in the pipeline. So we'll let that finish. While that's going on, what I want to show is, let's take a look. So this one, Jenga demos is actually what we're using for this one. And no, it's not. That's Docker demos, Jenga demos. And if we click on replications, you can see that we've got this replicated from East US to West Europe. That's just the two regions that we've got ACR build in currently. So that's what's happening when a build is done, and they're multi-masters, so they'll push to both sides. And what else was I going to show? I actually showed the, all right, so there it is. It's actually done. So now my build is done. Notice that it's the same tag that pushed in. So Kubernetes says, I already have that tag running. I'm going to be efficient and not update what's already there. It's trying to be optimized. So if we come over to our site, we'll notice that it's still green everywhere, and so is West Europe. Well, now let's go and play whack-a-mole here on our pods. And I'm going to go and let's see, how many deployments do I have? I think I've only set it for 2. So my web is currently set up with 2 deployments. So I'm load balancing between 2. In fact, if we look closely, we can see the host name changing, and you can kind of see down below the environment variable order is changing as well. So I'm going to come over here, and we'll go to the pods, which is the instances of those web, and I'm just going to go die. And so I killed off 1, but Kubernetes knows you asked me to keep 2 running. So we'll see, and it's going to be almost instant. And now, when I refresh this, after it brings back the second one, what are we going to see? What are we going to see? There we go. So as I'm cycling through this, in fact, if I go to deployments and go to web and scale this up because my workload started happening more, as those new nodes come in, it's just going to create more randomness. So let's finish up. So tagging techniques, stable tags are what you want to, this is kind of the model of stable tags. I have versions, and I can point them to each one, right? And I'm going to bring them forward. Version 1, it's going to keep on changing. Version 1.2, in this case, I want to have minors that are known as well. Latest is always the latest, which means it's completely random, and you should only ever use latest for demos. Please don't use latest. Like, friends don't let friends use latest. Is that a thing? I don't know, except for demos. Framework teams will serve as tags that, so 1.1 is actually going to move forward as well, right? Because we want to make sure we're putting updates in that. I'll just skip through this quick. Unique tagging, every build is unique. I don't care if you use the build ID that we give you. I don't care if you use the milliseconds of time. Make sure that every image you build is unique. In ACR, we use a base 32 number. The first 2 digits represent the region. The next 2 is 1 through 9, A through Z, minus a couple of letters that look too much like numbers. So now, if you're building frameworks, use stable tags. If you're deploying, use unique tags, and you won't get the instability. Because stable tags, deploying stable tags creates instability. So, wrapping up. If you accept failure as the norm, you can sleep, right? Don't try to strive for perfection. It is unachievable. Containers are immutable, so you want to be able to rebuild these. If you're setting up your pipelines with unit tests and automation, you can be successful. I like to think of automated tests as fluffy pillows, right? You can sleep better at night. And there's, I did an article on this, on deploying stable tags creates instability for more detail. If you, let's see, there's a whole bunch of links in here. I'm going to give you, let's see, where's the one link? If you go to ACR presentations, you'll find this deck. Okay, that's going to point to an ACR subfolder on GitHub, and that's where you'll find the deck, and you'll be able to click on all the links and get all the details. We're late. I ran a session yesterday on that you can watch on video, and with that, I want to thank you, ask you to complete subscriptions, complete your evaluations. Thank you for staying late. I hope you have a great conference.